Good day everyone. In this video, we will talk about chapter 17 of the Data and Communication 10th edition by William Stalling, which is entitled Wireless Transmission Techniques. So this chapter starts with a quote, "All creative people want to do the unexpected. Ecstasy and Me, My Life as a Woman" by Hedy Lamar. So, human creativity is what drives us forward as a species. This unique ability to harness our thoughts and ideas has generated some of the world's greatest inventions right now. One of those ideas is our topic for today. So, when we talk about wireless communication, we are already known that it refers to the communication or transmission of information over a distance without wires, cables, or any other electrical conductors. But the question is, how do these things interconnect with each other using networking? So this chapter answer the question by examining some key transmission techniques and technologies that are relevant to the wireless network and that are key to the latest generation of Wi-Fi and our cellular network. So MIMO antennas, which stands for multiple input and multiple output. So MIMO antenna architecture has become a key technology in evolving high-speed wireless networks. MIMO, ex- MIMO exploits the space dimension to improve wireless system in terms of capacity, range, and reliability. MIMO technologies are the cornerstone of emerging broadband wireless networks. So for example, those networks that we use in this present time, which is Wi-Fi and the 4G and the latest, which is the 5G. So MIMO refers to a practical technique for sending and receiving more than one data signal simultaneously over the same radio channel by exploiting multi-path propagation. So this allow wireless access points and devices to simultaneously transmit or receive multiple streams of data between each other. So it also helps also to ease the burden of congestion and increases the speed of the connection. So, so this figure represents the MIMO scheme. So as you can see, there is a transmitter with a multiple transmit antennas and a receiver that also has a multiple antenna receiver. So this transmitter is consisting a data stream that is divided into substream. So this box represents the substreams, and this triangle shape represents the antenna. So the individual substreams are the input of transmitting antennas. So these are the inputs, and so each of these antennas consists of a substreams. So when the transmission begin, there is a fading channel coefficient. So these lines or arrows this represents the channel coefficient. So this happens between the transmitter and the receiver antennas. At the receiving end, the antennas receive the transmission from the source antenna view- via a combination of line of sight, which is this, and a multipath, which is using another device for transmission, which represent in this figure as object. So with a lot of complex math, and the result is much better received signal than can be achieved with either a single antenna or multiple frequency channel. So the MIMO system is a collection of large fading channel. So MIMO system are characterized by excuse me. So there are two types of transmission scheme or MIMO transmission schemes. First is the spatial diversity and the spatial multiplexing. So spatial diversity is when the same data is coded and transmitted through multiple antennas. which effectively increase the power in the channel proportional to the number of transmitting antennas. This improves signal-to-noise or SNR for cell edge performance. Further, diverse multipath fading offers multiple views of transmitted data at the receiver, thus increasing robustness. In a multipath scenario, where each receiving antenna would experience a different interference environment, there is a high probability that if one antenna is suffering a high level of fading, another antenna has sufficient signal level. While in spatial multiplexing, a source data stream is divided among the transmitting antennas. So the gain in channel capacity is proportional to the available number of antennas and at the transmitter or receiver, whichever is less. Spatial multiplexing can be used when transmitting conditions are favorable and for relatively short distances compared to spatial diversity. The receiver must do considerable signal processing to sort out the incoming substreams, all of which are transmitting in the same frequency channel and to recover the individual data streams. So, so in this figure, this is a 3 by 4 MIMO schemes. So there are 3 antennas here in the transmitter and 4 antennas in the receiver. So just like one, there is a fading channel, fading coefficient channel. So the relationship between the receiver and transmitter's signals on different antennas is by a system of linear equation. So this is the linear equation. So the dimension of this is composed of a transmitter vector, which is three. There are three transmit antennas, which is there are also a three transmitter vector, and a four receive antennas, which is four receiver vector. So this H is a channel matrix. So in this system, the vector of received signal is expressed as a product of the channel matrix. So multiple user MIMO or MU and MIMO it extends the basic MIMO concept to multiple endpoints, each with multiple antennas. The advantage of multiple user MIMO compared to a single user MIMO is that the available capacity can be shared to meet time-varying demands. So multiple user MIMO techniques are used in both Wi-Fi and 4G cellular networks. So we also use multiple user MIMO in the latest gen, which is the 5 gen. So the main benefit of multiple user MIMO is that instead of each stream being systematically interrupted, and multiple user MIMO access point can keep its signals constant for the connected client devices and properly distribute the bandwidth to each of them without compromising any device's speed at the same time. So it also helps increase the network capacity and improve the performance of the network. So there are two applications of multiple user MIMO. First is the uplink, which is which is, which is multiple access channel or the MAC. So multiple end users transmit simultaneously to a single base station. And the second one is the downlink, which is the broadcast channel or BC, which is the base station transmits separate data streams to multiple independent users. So MIMO MAC or MIMO multiple access channel is used on the uplink to provide multiple access to subscriber stations. Excuse me. In general, MIMO MAC systems outperform point-to-point MIMO, particularly if the number receives antennas is greater than the number of transmit antennas at each user. A variety of multi-user detection techniques are used to separate the signals transmitted by the user, while MIMO BC or MIMO broadcast channel is used on the downlink channel, which enables the base station to transmit different data streams to multiple users over the same frequency band. So, in short, MIMO-VC is more challenging to implement. The techniques employed involve is processing of data symbols at the transmitter to minimize inter-user interference. So that's all for my report. This is just a part 1 of this chapter 17, and thank you.